Odds are very similar to probability. I have to add in that this is odds against. There is something also called odds for, but it's very rarely used. So usually when you see odds, it's odds against. And we have to change our language a little bit. For probability of an event, it was the number of events, the things that you're looking for, divided by the number of outcomes, all the possibilities. What odds do is kind of separates it into something else. Odds, instead of talking about events and outcomes, they talk about successes. Is there 2 C's in successes?
Yes.
It always looks so weird.
Sorry about that.
That is such a weird word. And failures.
Oh.
Of course, from now on, I'm going to call successes S, and I'm going to call failures F. So how are these interrelated, this idea of odds and probability? Well, if you talk about the number of events, those are the things you're looking for. So events become
Smaller than outcomes.
successes. So event is the same thing as a success. So what's a failure?
Outcomes.
It's not all the outcomes though, because all the outcomes have some of the
It's
successes.
the outcomes minus the success.
Outcomes minus success. So failures is equal to outcomes, all of them, minus or get rid of your successes. So they are kind of interrelated to one another. And there are cool little formulas that bring you back and forth. Okay. So when we talk about odds, let's just talk about straight odds, and we'll meld in probability later on. If you have an odd of an event, you're going to write it as failure, colon, success. It's actually a ratio. And it's used in gambling a lot.
Uh-oh.
Yes, I'm going to teach you why not to gamble. So, for gambling purposes, you always use odds against. And let's say you go to a horse race. And nobody has a 7 to 10 chance or odds of winning.
So what's the name is nobody?
Now, what's the 7 mean?
7 out of 10 times they'll win.
Nope.
7 out of 10 times they'll lose.
7, they lose. 10, they
They win.
win. Now, be careful of the out of language. Out of is a probability. So, the way you read this is 7 to 10, not 7 out of 10.
So
this
the
is,
semicons means two.
What does that mean?
what does it mean?
Yeah.
That means if they run 17 races,
No.
7 times they will lose and 10 times they will win. Alright, so what happens at a betting track is you bet $50. Let's say nobody wins. Doesn't that sound cool? Nobody wins. Name of the horse. If they win and you bet $50, number one thing happens is you get your $50 back, which is kind of nice, but it's not winning, that's just getting your $50 back.
Breaking even.
To find out how much you win, you have to take your $50 and you multiply it by the fraction form by 7 to 10. But you write it in fraction form, but it's not a probability. So it's still 7 to 10. Don't read that as 7 out of 10. That's something totally different. So to find out how much you win, you take how much you bet and you multiply by the failures over the successes. So that fraction is always going to be failures over successes to find out your winnings. So what's this equal to?
3.5.
What is it?
It's gotta be more than that.
Oh, you're all all typing into your calculator. I'm so sad.
What was the?
10. What's this equal to when you multiply it all out?
35.
35.
Yeah.
10 goes into 50 5 times. 5 times 7 is 35. So you win $35 plus you get your $50 back. But basically your profit is only $35. So when does your profit go bigger than how much you bet? You know, I'm going
You
to bet
gotta
50.
make more money.
Yeah, but what has to be true about the odds? More money, sure.
Odds has to be smaller,
In what number has to be smaller?
and the successes.
The success part, right? If I drop my successes, I'm dividing by a smaller number, therefore my answer is going to be bigger. So when you're looking at odds, you are going to bet on things like 8 to 1,
Uh-huh.
because that gives you 8 times as much money as what you actually bet.
Uh-huh.
So the bigger number in the second part actually means you win a little bit less. And if you think about it, 10 successes is bigger than the 7 failures, therefore you shouldn't win that much because you're expecting the horse to win. So if you see a horse that's 1 to 8 or 1 to 10, what's the point of betting? You're only going to get a tenth of the amount of money you actually bet, because more than likely he's going to
Lose.
win. Win. This is failures. This is successes. Alright, so that's how odds are used for gambling. Partially. Lottery. They will advertise the odds for you. I think some of them actually, like McDonald's Monopoly game, you turn it over and look at the odds.
Yeah.
They do odds for. All they do is switch the successes and failures. No, wait a minute. They might do odds against. I haven't looked at it recently.
Excuse me, I'm not trying to take up much of your time,
Go for
but
it.
on the back of the lottery scratch off, it has the odds.
Oh,
of
look, he's got one.
I was fighting, I
just got
got
it.
one right
He's
here.
got one. That's awesome.
1 in 4.07.
1 in 4.07.
Oh, you talking about?
I haven't figured it out yet.
Now, more than likely, this is odds 4. You have 1 chance at winning out of, and 4 chances of losing.
So it's not saying if I buy, I was assuming if I buy 4 tickets,
One of them wins.
exactly.
5.
5
tickets. Because you have to take these two and add them together.
Didn't know that. Thank you. Seriously.
But
That's
even
five
then,
or six is done.
you're falling under something called the gambler's fallacy. In the sense of your probability of winning each and every ticket is related to these numbers, but they don't change because you buy an awful lot of them.
Right.
There is a possibility that you buy 100 of them and none of them are.
Oh, well.
It's a very small chance, but still, it's a.
I was
A
seriously
chance.
curious about that.
I'm going to tell you right now, do not play the lottery. This is why I have you doing the stock project.
Thank you.
For instance,
Okay.
the Powerball.
Yes. Oh, that's always one out of 4 million.
There you go, right here.
The Powerball, you pick.
175 million.
You pick 5 numbers between 1 and 59.
Yes.
You get to pick 5 balls numbered 1 through 59. If you get all 5 of them correct, pick 5. I had to look this up. You win $2 million. So even under the Powerball, if you don't get the Powerball itself, you still win $2 million if you pick the original 5 numbers. The second thing is that one number you get to pick separately. You have 1 through 35 to choose from, so basically 35 numbers. If you get the 5 numbers up here and the 1 number down here, you win Powerball.
Yeah.
Isn't that exciting? You know,
Would be.
$100 million. You know, a couple weeks ago it was 100 million. No,
It was way 500 million.
500 million, right? So, what is the probability or the odds of winning at least the pick 5? Well, this is really sad. Failures to successes. This one turns out to be 5 mil to 1. What's that mean? 5 million chances of actually losing and 1 chance of winning.
Ain't that how it's supposed to be?
So you're telling me that
Ain't it how it's supposed to be?
Yeah, but the point is you're
So there's
basically
not-
taking your money and
Throwing it away. Give
Giving it away. To win the Powerball, the 1 out of 35, the chances are even better. Oh, this is wonderful. 175 million.
They got a thing now where if you miss it by one number, you can still win.
Get a little bit of money, yeah, but
Get
still,
$1 million.
to win the Powerball, 175 million to 1. Now, the way the Powerball works is if there's no winner, the pot goes up. How many people live in the United States?
A lot.
300 and some million.
300 and some million. Half of them might play, no, I wouldn't even say half of them, I would say a quarter of them would probably play the Powerball. Even if you take a quarter, if every single person that was going to play the Powerball played the Powerball, there's still a chance that they don't win. There's no winner at all.
Alright, let's tell it.
I'd rather them tax everybody instead of depending on people that think they're going to win. Because the types of people that think they're going to win are not the ones from the upper class. They're the ones from the lower class. Can they afford to spend that money? I say tax everybody.
Let's do this.
Get rid of
What
the
about the sweepstakes headquarters, like the internet cafe?
Oh my God.
Don't even go there by them. Oh my God.
I won $500.
I'm scared of those places.
Oh. They-
No way.
I'll get to that.
Okay.
No way.
Wow. Those things are horrible.
They sure are.
All right, so
I know too many people that live in places.
to probability. To change an odds to a probability. This is interesting. So, odds, they are written as failures to successes. Probabilities are written as number of events over number of outcomes. And we've already talked that events are the same thing as successes. So we can start off by saying, well, the probability of an event is equal to a success over. And the number of outcomes is a mixture of failures and successes. So how do I get the bottom number in terms of failures and successes?
Failure minus success.
Um,
Success minus failure.
Probably.
I want all my outcomes to be in the bottom. Add them. You're going to have successes and you're going to have
Failure.
failures. So you get successes plus failures. So the probability formula in terms of odds is S over S plus F. All right, so if I have odds of 5 to 20, which really should be written as 1 to 5, but I'll leave it as 5 to 20, the probability of that event is going to be, the first one is failures, the second one is successes. So what number goes on the top?
20.
20. What number goes in the bottom? 20 plus
Oh, right.
5. The failures plus, or the successes plus the failures. So this becomes 20 out of 25, which reduces to 4 out of 5. Now the language changes. This is 5 to 20. This is 4 out of 5. So if you have a 5 to 20 odd, you have a 4 out of 5 chance of actually the event occurring. In other words, rather high, that's 80%. All right. What if I have odds of 14 to 7? Nah, not 7. 9. 14 to 9. What would be the probability of the event actually happening?
14 over 2.
What goes up top?
9.
9. Because this is successes. What goes in the bottom? The first one you write is
9.
9 again, plus
14.
14. So this becomes 9 over
23.
23. Or 9 out of 23. Does that make sense? All right. So let's change 5 million, our 5 mil to 1. Now, the way they write it is, well, this is written failures to successes. You have 5 million chances of losing. You have 1 chance of winning success. So the probability of actually winning the lottery is what?
It is 1 over
1 over
1 plus 5 million.
5,000, comma 001. 1 over 5,000,001. 5,000,001. All right. This even gets better. What about the 175 mil to 1? What's the probability of winning the lottery's Powerball?
It would be 1 over
1 over
1 plus 175 million.
1,750,000,001. Now in this case, the 1 really doesn't change the answer that much. This one's really close to 0. This one's even closer to 0. Type that in your calculator. 1 divided by 175,000,000,001. That. Tell me what the answer is. Guarantee it goes into scientific notation.
Nope, you're wrong.
Point
It's in-
0,000,000.
Point zero
It's
zero.
1, 2, 3, 4, 5, 6, 7, 8 zeros and then a 6.
7, 8 zeros, and then a 6. There's your probability of winning. You have better luck getting struck by lightning twice in the same day. The probability of getting struck by lightning is about 4 zeros and a number.
Yeah, because that's different.
Plus, all that money doesn't go to schools, which is insane.
People still.
You know, they say
Kids
they
still hungry.
give money to the school, but the school system's always saying that they don't have no money. So, I mean, what's really going on?
It depends on how it gets moved around.
Now that money
So
go
they
to the
spend it all
one, the
on-
teachers that they show on the news in the morning. They get the little
Yeah,
trophy.
yeah,
They
yeah,
take the
yes.
money and buy little stuff like that.
Now, the one I do agree with, I think it was South Carolina or Georgia, they took their lottery money and students that earned a B average in high school automatically got a scholarship to go to community college.
That's not.
Automatically. And they didn't put it to the schools, they put it to the students. All right, probability to odds. Silly thing, where you done?
Yeah, but if they do that, then they.
So if you have a probability of an event is 8 out of 25. Now I'm reading that literally the way it should be read. 8 out of 25 chance of it actually happening. How do I change it to an odd? Well, I got to recognize that this is the same thing as successes over successes plus failures. So I just got to figure out what the pieces are. What's my successes? 8. Successes again in the bottom, that means it has to be 8 plus something. What is the other number that comes up with 25? In other words, what's 25 minus 8?
17.
17. So this is your successes, and this is your failures. So how do I write it as an odd?
17,
2,
8.
8. And that's all there is to it. So you're just ripping apart the denominator to figure out what your failures are. If you have a probability of an event is 9%, written as a percent, how would you change it to an odd? Well, the thing you need is a fraction. So how do I write 9% as a fraction? 9 over 100. And then you want to break it down into 9 over, and the first number you write is 9. Again, to get it into successes and failures. What's left over?
91.
91. So my successes is 9, my failures is 91. So this odd would be 91 to 9. So you'd have 99 failures and 9 successes for a total of 100 possibilities.
Oh,
You
I
said,
can't see that. I can't see that.
Oh, okay.
What you say?
What?
What's the last thing you said?
You have 91 failures, chances of failing, and 9 possible successes out of a total of 100.
Okay.
To find out your total number of outcomes, you take these two numbers and just add them together. So up here, the total number of outcomes is 25, and so forth and so on. All right.
Do you want to, if you get to, if the odds were 81 and 9, do you want to simplify that down? Or
Yes.
do you want
If you have odds that are like 81 to 9, you really should be writing this 9 to 1. So it reduces likely fraction. even though it's really not. The two language allows you to reduce. And yeah, in Moodle, it asks you to reduce them, so be careful. All right, so that's odds. I mean, it's not that hard. And it's really only related to gambling, like on football games, horses, when Vegas comes up with their odds. We'll come back to odds in a little bit when we talk about casinos. Expected value.
Is that in the book? Mr.
This is in the book. Section 5.5.
Okay.
This is important because this is going to show you your chances of winning money, basically. It also relates very well to insurance. You know, how do they figure out how much to charge you? If you've been in a wreck in a car, why do they jack up your rates? If you're a smoker, why do they jack up your rates? So forth and so on. And there's reasons behind it all. So expected value kind of works out this way. For example, kind of like a carnival game type situation. That's also how basic casino games are designed. They design them in such a way that the amount of money you bet, some people are going to win, but most people are going to lose. And casinos set it up in such a way that they never lose.
Right.
And the way they figure that out is this idea of expected value. It deals with pure theoretical probability and the chances of winning a certain amount of money. So let's say that there are 10 red, 5 blue, and 2 white rocks in this container that you get to pick from. Right now, you don't have to pay money into this game. What we're trying to find is what's called the fair price. So the way you should set up expected values is a table. And what you're going to do is put what could happen up top. So what could happen when you reach your hand into this bag and pull out a rock?
You're gonna pull out.
Well, you're going to pull out a rock, and what's it going to be?
It's gonna be colored.
What color?
It's
Red,
blue,
blue,
white.
or white?
Right.
So the top of this is going to be red, blue, or white. So some kind of description of what's going to happen will go on the top of your table. All expected values should be set up this way. I don't know how much I can emphasize that, but no one ever listens to me. I don't know why. The next line should be your winnings. If you select a red rock, you win
$2.
$2. If you select a blue, it's $5. If you select a white, it's $10. I just made up the number, so I have no idea what's going to happen. The line under that should be the probability of that event actually happening. Yeah.
The line in blue, I can't, what is that? Is that how many rocks there are? Right there.
10 red, 5 blue, 2 white rocks. Thank you, Mr. Kalorn. Oh, here he comes. She won't even look at me.
Closer. I was just wondering if my markers were shiny or something. Alright, so if you reach your hand into this bag and you pull out a rock, what is the probability of it's actually red?
10 out of
10 out of the 17.
10 out of 17. Alright, so that goes 10 out of 17. And if you reach in and pull out a blue, now you're not pulling out a red and looking at it and holding on to it. You're assuming that you're restarting the game every time. So what's the probability of that rock actually being blue?
5 out of 17.
5 out of 17. White?
2 out of 17.
2 out of 17. After you get this down, that's all the work there really is. The rest of it is calculator. Your calculator is going to now take these numbers and multiply them together. Take these numbers, multiply them together. Take these numbers, multiply them together. And then take all your answers and add them all up. Because it's either going to be a red one or,
A blue one.
or,
A white.
and or always turns into add. So it's going to be 2 times 10 over 17 plus 5 times 5 over 17 plus 10 times 2 over 17. And you hit enter and you get a nice little answer.
One second.
One
It
second.
didn't come out like that. That's what I did. It just didn't come.
Let's see what we got.
You know, I did something.
Well, mine might have prices too. That changes.
Yeah, I got
things.
prices.
That's what I'm saying. Prices as in how much does this game cost?
Oh,
We'll talk about that in a second.
okay.
So, what is it?
So I didn't finish it.
No one has a calculator?
I can't
Hold
really see that.
My
Good
miss
Lord.
15 minutes late is getting.
Well, you know,
Is it just
the kids
coincidence
got
that
out.
there's
I don't know if I
two
did
white
mine right or
rocks?
not. Is
What'd
this
you
right?
What's your 2,
What'd you
5,
get?
and 10, and then there's 10, 5, and 2?
I just made up numbers.
No,
There's
this is
no
what I got.
rhyme or reason why it would work
3 point.
any which way.
I don't know.
What'd you
I
get?
probably didn't enter in right.
3 point.
8235.
Now this is money, so
Oh, so you were right.
$3 and
82
82
cents.
cents. This would be the cost of the game if you were going to make it fair. That means no one's eventually going to win and no one's eventually going to lose any money. It comes out fairly even. So this would be considered the fair price.
So if you charge $4 to play a game,
The casino's going to make money, one way or the other. So if you charge $4 a game, the casino's going to make, what's that, 18 cents every time someone plays, on average. Not every single time, but on average, they're going to win 18 cents per play.
So is the 382, that's all three of them together, correct?
It's if you pull a red, it's the expected value of this game.
Okay.
That if someone played this game, they would expect to win $3.82 every time they play. Now, obviously, they're not going to win exactly $3.82 because they only get to win 2, 5, or 10. It's on average they're going to win $3.82. So if they played 10 times, they would expect to win $38. 100 times, $382, and so forth and so on. So-
$3.82.
Play 100 times, this would equal $382. You would expect to win $382 playing this game, on average. Now, if you're a casino, you make the price $4, $5, $6, something bigger than $3.82. If you make it smaller, what happens to your casino? You're going to go out of business because all you're going to be doing is paying out money. So it depends on your point of view if that number is positive or negative. It's positive in this sense for the player. The player is going to win $3.82. But for the casino is going to be losing $3.82. So where one is going to win something, the other one has to lose. Otherwise, you're not magically creating money. All right. Once you get this idea down, then things become a little bit easier. Not a lot. What should we do? Roulette? Roulette. Does anybody know roulette? Big wheel, has red and black on it and 2 greens. No?
Yeah.
I didn't know.
Tourists. That's what the statisticians at insurance companies are acturists. Are you done?
Yes, sir.
Insurance.
Yes, sir. Yes, sir.
Let's go with life insurance, much easier than the other ones. Life insurance, what is it?
They're
Insurance
expecting
for
you
your
to
life.
die.
So there's
Not
only
die.
2 chances with life insurance. You live
Live or die.
or you die. Now generally when they sell a policy, and I'm not talking about one that you get through your employer where you pay a little bit every month and you can keep it year to year. I'm talking about you buy a year's life insurance. So, let's say we're talking about a 45-year-old male smoker. Wants insurance.
God help him.
Now, of course, you have different levels of insurance, and of course, as if you go from 50,000 to 100,000 to 175,000, the amount of money comes out of your pocket is a little bit
Higher.
higher. because he's a smoker, it'll be a little bit higher. As he gets older, it'll get
Yeah.
higher, and so forth and so on. They actually have tables of probabilities of each one of these groups of living for the next year or dying over the next year, pretty much. So if he wants to buy a $100,000 life insurance policy, it will cost him, let's say, $580
Come on.
for the whole year. $580.
That's a lot.
So this is a 1-year insurance policy. So basically, the insurance company is betting that this man is not going to.
Yeah.
I mean,
If they knew he was going to die, they wouldn't give him the insurance. They're hoping that he'll more than likely live, and they get to
so
pocket
they could get the money
$580.
every month,
Right. But just in case he does die, they're going to lose
the 100,000.
minus $580. But we'll talk about that in a second. So if his probability of dying on that table is 0.0, oh, what's a good number? Oh, I
It's
didn't
on
write
the
one
chart.
down here. 031 over the next year.
Let's get back to
This is how insurance companies figure out if their policy is going to make them money or not. They do a expected value table, and there's only going to be 2 columns:
Live and die.
live, die. Really sad, but that's how they look at things. So you set it up exactly the same. What's going to happen if you live?
You're gonna
Well-
keep paying the 580.
You're going to pay that $580. So since you're paying it out, it's going to be a negative $580. You bought the insurance policy. If you lived, therefore they don't have to pay you anything. They get to keep your $580. Now the other part of it, of course, is you could die. Now, when this guy dies over the next 365 days, the insurance company is going to cut the family a check for $100,000. Is that how much they're getting?
No, you gotta
No.
strike out the 580.
Yeah, you got to get rid of the 580 because you lost that money to begin with. I always think of it as like inheritance. That $580 would have been there for inheritance purposes, but he took it and spent it someplace, and they're only going to give him back the $100,000. So when you get to the die part, it has to be the amount of the insurance minus how much it costs to begin with. Which is what? 99. Y'all have calculators, right? We don't like
Lord have
them.
420.
420. So they would cut a check for $100,000, but the amount of money going back to the family is only $99,420.
Ain't you gotta pay taxes on it too?
Well, yeah, but I don't get into that. This is just the insurance company. So, what is the probability? Remember, this is what could happen, and then down here I want the probability of the event actually happening. What is the probability of them actually dying? Well, I didn't write it as a percent. This is just a straight decimal, so it's
Oh, it's the minus.
0.0031. What's the probability of living?
a lot more.
How would you find it?
Subtract it from 100.
What's the
Well, subtract it
opposite?
from
100. 1.
1. 100 if it's a
One.
percent, 1 if it's a decimal. So this is going to be 1 minus
the-
0.0031,
69.
99,
69.
69, 0.9969. All right, so for calculation purposes, you take this number and you multiply it by that number. You take this number and multiply it by that number
So what
and add them together.
you say? Multiply the negative.
Yeah, so you go negative 580 and you times it by
0.99.
9969. And then you're going to add on to it the 99420 times
0.0031.
0031. And hope to God I chose decent numbers. So,
What are we finding out?
the expected value of this insurance policy. Whether it's worth it for the customer or if the insurance company's gonna go out of business. One of those two possibilities. Since I made up numbers, I have no clue what's gonna happen.
-270.
Yeah, it's not really,
How much is it?
like 58,000.
Positive?
Oh, what did I do
Maybe I did
wrong?
something wrong.
Oh,
I could have done
I
something
might have made my probabilities too. I should have stole one from Moodle. Those are set up rather nicely. So negative 580 times 0.9969 plus 99420 times 0.0031.
negative 2.7?
Negative 27.
That's what I had.
So, if you are the customer, this policy is actually going to, on average, lose you $270. So this insurance company is charging
200.
way too high.
Yes.
So this is one way you can shop around for insurance companies to see which ones are going to
Don't
be
erase
better
that yet.
price.
Hold on, hold on,
I'm not
hold
erasing anything.
on.
So if the customer is losing $270 in an insurance policy, then the insurance company is making
200.
$270 every policy they sell at this level.
Every year.
This is why insurance companies make tons and tons of money. Sure, they're going to pay out $100,000 every once in a while, but most of the time they're going to be collecting the $580.
So you're only really getting your money back. What you've been paying out all these years.
Well, but even if you're just doing it for 1 year, more than likely you're just paying out your money.
Right.
But if you do die, they do pay you the $100,000. But as a company, they're still going to make a profit.
Mhm.
Unless everybody dies.
I still said that. I must be doing something wrong.
You gotta do the rest too.
You clear state.
It is around like, the edge is around like where these bushes and stuff are. We need to go home.
Why?
Because I got a 45-minute ride home. I gotta get on 95.
You realize you're being recorded right now, right?
Well, you can edit it.
Yeah, I still do.
Oh, I swear.
I don't know, they do something
But 99.
Oh, it's a point.
Moments.
Let us leave.
Well,
Let us go home.
why? Because all our brains aren't working?
Right. I mean, I keep learning things.
Alright, so that's expected value. It's not that hard. There's short little videos online that if you get lost, they show you how to do this stuff again. I don't know what it is with people, but multiplying these numbers together causes problems, which I can't understand because all you're doing is typing them into a calculator. So just be really careful with this, that minus sign. And there's two styles of expected values. This one includes the minus. The ones I showed you before didn't include it until the very end. So if you're playing multiple step game and it costs you amount of money, just set up how much money you're going to win and take away how much money you're going to lose at the end. It's much easier that way.
So I know how to find it now, but what is that number?
I have to explain it again.
I'm sorry.
This is how much money the person buying the policy on average is going to lose. So on average, each customer that buys this particular policy is losing $270 on average. Even though somebody is still going to get $100,000 out of the mess, most of them are going to get paid about half of what they put into the policy. So on average, as a customer, this doesn't mean anything, but as an insurance company, it means they're earning $270 every policy. So if they sell 100 policies, they've made $27,000. That's a lot of money for doing basically nothing.
Yeah.
Oh,
Entering in a bunch of numbers.
yeah. All right. So to continue on, the next topic is chapter 6 in the book. And again, it's a bunch of little pieces that have to go together. So the first part is central tendencies. Of data. Depending on how you read it, data. And it's also singular and plural. So what does it mean to be data? Information that you collect about something. Grades are usually what teachers look at. So they collect all this grade data and they do calculations and they figure out, on average, where's the center of the class. So when we talk about central tendencies, we're talking about, out of a whole list of data, where basically is the middle. And we've talked about this all year, the median household income, the mean height, things like that. So central tendencies in data are mean, median, and mode.
This is the easiest part of math class all semester.
Just wait, it gets better. This is 2 minutes of lesson and then I go on. The mean is, add them all up. Divide by how many? Basic average. Most people consider the mean the average. But average has that connotation, it could also be the median. So you have to be a little careful. When we talk about data, symbolically, data itself we're going to call X, big capital X. The mean actually is X with a bar over it. So you start seeing bars on top of variables, you start thinking average mean. That's usually what it means. The median is line them up. When I say them, what am I really talking about?
Oh, the numbers.
The data.
Data.
Them. Line them up. Line them up. And pick the middle. Now, when you line them all up, they have to be in order. So smallest to largest, largest to smallest. You can't just randomly have them all over the place and grab the middle number. It means nothing. When we talked about the median household income being about $45,000, you lined up everybody in the United States according to their income and you picked the middle person. Mode is probably the easiest of all of them, the most frequent.
What's the,
Is that what you see the most? Is that what?
what's the X
Oh, yeah.
This X?
for median?
What's the one for me?
Oh, there is none. Nothing for median.
What about mode?
There's nothing for mode. These two don't have any special symbols per se, but mean is very important, so it gets its own little symbol.
The most frequent, that's just the one you see the most.
The one you see the most. So if you look at the population, most guys are about 5'8".
Oh my God, I hate to interrupt class. On the way to school this morning, listening to ACTJ, and there was this guy on it talking about he was short. He was 5'8", and he was short. And I mean,
That's not short.
I know that's what they were trying to tell him.
Maybe a little bit short, but
That's
not
what they were
horribly
trying to
short.
tell him, but it was just a whole big old conversation about.
I call myself.
I guess if you're hanging out with the NBA, yeah, you're short. Those guys are, 6'8", 6'5". It all depends on the population around you, I guess. If we moved to the pygmy land of Africa, where all the really short people, I'd be a giant.
Where's Oxford? That's where he was from.
Oxford?
He said that all the guys there were over 6 foot, and the women
Oxford,
were almost
Connecticut?
6 foot. And
Women are. He's crazy. Maybe he doesn't know how to measure things very well. I swear.
Why you put pig in quotations?
Oh, picking the middle is kind of interesting. Let's do a quick example.
1 or 2.
Example, let's say we have a data set of 2, 4, 7, 9, 11, 21, 38,
Why not?
40, 41. So here's a list of data. The nice thing about this list of data is it's already in
Order.
order. The ones I give you are not in
Order.
order. You have to first put them in order to do the median calculation at least. Oh, I should have made two of the numbers exactly the same.
2 of them.
No, don't switch it.
Oh, I want to. We'll leave mode off for a second. Mode is not really the most important one out of it. Actually, the median and the mean are the most important two for central tendencies. So if I'm going to find the mean, there's a formula for it. It's x bar, that should be that, equals, when you're looking at a spreadsheet, have you seen that symbol anywhere?
No.
It's not on there?
No.
I'll have to look at Google Sheets to see if they have that button. On Excel,
Yeah, it's on
Can I ask you a
there.
question?
yeah.
It's about Google Docs. Once you write a document in there, you can upload it to Moodle, right? Or you can't?
You have to download it as an Excel sheet and then upload it to Moodle.
I'll show you.
Okay. Okay, yeah, it is, but what if you put it on it, like you, already type it into a Google Doc, and then you try to upload it, open it in Word, will it do it like that, or it won't?
In Word or Excel?
Yeah, Excel.
It'll work open in Excel.
See,
You
I
have to,
did that
you have to go to
yesterday.
File, Download, Excel.
If you don't do that, then it's
You
not
can't
going.
do it. You have to download it from Google Docs to your computer and then open it up in Excel. It doesn't chain right
Okay,
to
so
it.
like if you save the document to a flash drive and you try to open it up in Word, it should pull up and
Depends on how you saved it.
If you didn't download it, it's.
If you didn't download it, it's not saved. You're saving a link to Google Docs.
okay.
You have to literally go to File, Download, save it as Excel.
Okay, and then you can pull it up.
Then you can put it wherever you want and open it up anywhere.
Okay.
Because then it's just a file rather than a web address.
I'll just show you in class.
That'd be fine. So, what your formula is going to look like is this symbol, which means, anyone want to guess?
Average.
Add them all up, literally. It means add them all up. This is the summation symbol. It just means add them all up. And you're going to divide by how many, and we're going to represent that with n. So n is always going to represent how many numbers are in the list. So how many are in this list?
11?
9.
9. So here n is going to equal 9. And it's always important to know how many are in your list because some calculations depend on whether it's odd or even. Even is usually harder, odd is usually easier.
Okay.
All right, so if you add them all up, what do you get?
173?
173.
173. And you're going to divide that by,
9.
and you get
19.2.
19.2.
Yeah.
And this number just represents the middle kind of the data. Not as in median middle, but your central tendencies. It's leaning towards your average of your class or whatever the heck this is 19.2. Median, on the other hand, only picks the middle value. So I consider grade school style where you take your fingers and you put it on the outside numbers and you just count your way in. That works fine for short lists. So 41 and 2, 4 and 40, 7 and 38, 9 and 21, so the median is 11. When it's an odd list, you get one number. So the reason I put pick in quotations is sometimes you don't land on a number at all. Or you might land on two of them. So here the median is 11. The mode, in this case, there is none. Because none of them repeated themselves.
You said you was going to put.
No, I didn't do that on purpose. All right. So what happens if there's an even number of elements?
You take the 2 middles.
You take the 2 middle, and you do and you average them. So it's not really a hard idea. Let's talk about grades. 65, 68, 73, 73, 81, 92, 92, 92, 1, 2, 3, 4, 5, 6, 7, 8, 93, 95, 100. 1, 2, 3, 4, 5, 6, 7, 11, darn it. Let's add a score at the beginning. 63. Now there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here, n is 12.
The number is 12.
The number of elements in this set is 12. So that makes it a little bit different than an odd one for median purposes, but everything else still works exactly the same. So if I wanted to find the average, you can add them all together, but I don't want you to, because that just takes up too much time. And divide by
12.
12, that's easy. What would be the median?
Those two.
81 plus 92.
So you go to 100, in one, in one, in one, in one. I can't stand doing it this way. And the middle is literally here, between two numbers. So you pick the one on the left and the one on the right. So 81 plus 92, and you find their average. 81 plus 92 divided by 2.
Divided by 2.
Because there's only two numbers you're looking at. But the median literally happens between those two numbers. It's not one or the other. What? 86.3. 5?
Yeah,
86.5.
I don't know where I got
86.5. Don't listen to Brooke anymore. She's getting crazy with her calculator today.
It doesn't like me.
It doesn't like me. This one is good for the mode. What's the mode?
92.
92. 73 happens twice, but 92 happens 3 times. Now, if 92 only happened twice and 73 happened twice, then you consider both of them your mode. It becomes known as bimodal, but it's pointless. So this one in this case is 92. Not that bad, right? Mean, median, mode. With that example there, let's go one step further. Why not?
I messed up on the deviation. That was the one that I
Standard
got wrong.
deviation, I got different ways to do it. Dun, 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 dun. Let's talk about spread, just a little bit. Spread as in, is your data close together, or is it really spaced out a lot? Now, if we're talking about household incomes, that data is really spread out a lot, way, way far out. So, spread. Let's talk about quartiles. Now, quartiles are related to medians.
You said he.
Quartiles are related to medians. Middles. They're related to medians. What did I say?
I thought you said heathens.
Heathens.
Very
You
simple.
heathens.
Okay, I'm so sorry.
I love life. Heathens. That's a good one. So basically, what you do is you take half of your data, and then you take those halves and cut them in half again. And literally you get down to a quartile. Quartile represents 25%, a quarter of your data. So we're going to break our data into 25% chunks, and we're going to have 4 of them. And then we can get into what's called a box plot from this information. So the first quartile, if you take information and you cut it in half, what does this become part of as your data? What's its name? This is the median. So if you cut it in half, it becomes your median. It's also known as Q2, which is quartile 2, the second quartile. 2 quartiles make 50% because 25 plus 25. If you cut the left-hand part in half, you get quartile 1. So there's 25% to the left of it, and there's 25% up to the median. If you cut the right-hand side, this becomes Q3, the third quartile. Way over here to the far left is your low or minimum, and way over here to your right is your high or maximum. So basically, this is all we're going to do to the data. We're going to have a high-low, we're going to have the median, and then we're going to cut the 2 halves into more halves, and have quartile 1 and quartile 3. Perfect data would look like this. But when we do this, sometimes that middle gets shifted a little bit left and a little bit right. So let's see what happens with this data up here. So quartile 2 we already know. What's the low?
63.
63. Quartile 1 we'll get back to. Quartile 2 we already know is,
81 and 92.
which gives you
86.5.
86.5.
Mhm.
Quartile 3 will come up with, and then we have our max or our high. I really should use min up here instead of low. Min. So what's the max?
100.
100. Okay. So how do I get the quartiles?
So- You're gonna.
63 is your low, 100 is your high, maximum, 86.5 is your median, and your median is the same thing as Q2.
Okay.
So where does Q1 come from? Well, Q1 comes from, since we cut this right down the middle,
You're gonna go
we need to take this side and say, where's the median? So if you do it the old style, you go
68.
in, and it becomes 68 and
73.
73. So again, your median is between these two. So this one is going to be 68 plus 73 divided by 2, better known as
Oh, hold on.
I put 60,
71.
like 71.
Oh, 70?
I was just pressing the button.
Excuse me, sir.
Yeah.
Why did you do that? Because that's the low side. So you do everything. Okay.
You take, from your median, you take the left-hand side and find the median again.
Yeah, okay.
So that became 70?
No, I still don't understand.
70? What?
Say, repeat what you said. one more
Okay.
time.
The median happens between 81 and 92.
Mhm.
So you take the numbers to the left,
Mhm.
81, 73, 73, 68, 65, 63,
Mhm.
and you find the median again. How do you find the median?
Same way we found it the first time.
You go to the middle,
Okay.
and the middle lands on these two numbers. Stop texting.
I was listening.
All
I was just writing it down.
Okay, come on, let's get
All right, what
it
about
one more
Q3?
time.
1, 2, 3.
Same thing.
Same thing, go to the right-hand side, find the median of those guys, which would be 92 and
93.
right in here. So you do 92 plus 93 divided by 100, the 100.
But,
2. I'm thinking percents for some reason.
92.5.
92.5. All right. So we have our, what's called the 5-number summary. 5-number summary of our data. So now we can do what's called a box plot. Different color. Box plot. Box plot. And to start it off, you just draw a number line. Over here, that'll be your minimum. Over here, that'll be your maximum. So our minimum value is
63.
63. Our maximum value is
100.
100. What I'm going to do now is reference marks, not Q1, Q2, or Q3, just reference marks. What's halfway between 63 and 100, approximately?
163 divided by 2 would be 81.5.
So about 82, right? So about halfway, this would represent 82. All right, what's halfway between 63 and 82?
145 divided by 2 would be.
Add them together, divide by 2, and you get
72.5.
72.5, about 73. So about halfway here would be 73. 182 divided by 2?
91.
91. So about halfway between here would be 91. And I only use these so that I can place the other numbers a little bit easier. So the other numbers I need to place. 63 I already got up there. The next number up is 70.5. So 70.5 is right about here. It's right about there, give or take a little bit. Doesn't have to be perfect. The next number up is
86.5.
86.5. That's right about here. Give or take a little bit. It's not perfect, but you know, you get the idea. Next number up is
92.5.
He's right about there. And you get those 3 dots. Now from those 3 dots, you're going to draw vertical bars. Just short, like half-inch ones on your paper. So I'm just going to draw it like this. Vertical bar there, vertical bar there, vertical bar here. Make them all about the same size. And you're going to draw a box around them. That box represents 50% of the information. That's the 2 middle quartiles, 50% of your information. Then you just draw a line out to your minimum and a line out to your maximum. And those 2 lines represent 25% each. So this data is leaning a little bit to the right because that middle line in the box is shifted to the right. So that means more of your data is to the right than it is to the left. A lot. Which means it's a good thing if it's a test. Yeah. I don't want to draw your test down here someplace. And the box would be way over here and 100 way over there. Ah, sad. So this is just a box plot. It kind of gives you an idea of how the numbers are distributed. A little short stick means that the numbers are rather close together in the first 25%. The second 25%, because it's a little bit longer, means they're a little bit more spread out. The 2 lines together in the third quartile area, they're close together, so that means all the data is rather squished, and the same thing from that to 100.
there too.
Yeah, so you get squished here because of the 92s, and you get squished here because it's only 93 to 100. But this group here, 73 through 81.
It was more passing grades than it was failing.
In that one, yeah, definitely. 75% of them almost. Actually, yeah, 75% exactly. So that's a box plot. Not that hard. If, and I'll write this up here. If you have an odd number, like if you had 4, 5, 6, 7, 8 as your numbers, what's the median here?
6.
When you write your median bar, it gets rid of 6. So then you just find the median to the left and to the right. That gets kind of tricky. So if it goes between them, you just kind of split the thing in half.
And if not, then just.
But if the median hits a number, you can't use that number again. If that makes any sense.
Yeah.
Once it hits it, it's gone. So then you just split your list from there. Now, if you do quartiles on a spreadsheet, that gives you totally different answers. Seriously, they do it weird. The formula for theirs is outrageously crazy. So what I want to show you now is spreadsheet style. Because who wants to do all these calculations? Not very many people, trust me.